the aim or the purpose why we need to titrate virus are mainly for diagnosis. Okay, for example, you want to perform a test, you need to know how many concentration of virus you have, and then it's also important to know the concentration of virus in when you want to produce a vaccine. Apart from that, you also need to know the concentration of virus when you want to do research, particularly when you want to infect cells with virus, or you want to infect animals in vivo using virus. Okay, in principles, if I give you a vial of virus stock, if I ask you how many virus in this vial, basically we can measure either the virus particle or how many infectious virus are present in a vial. So you can see from this vial here, in a stock of virus, most of the time there will be mixture of infectious and non-infectious particle. So basically, in order to measure overall or all virus present in our stock, regardless of either infectious or non-infectious virus particle, we can use electron microscope. Okay, basically you can count how many the complete virus are there in the samples, or you also can use immunological assays such as immunofluorescence, quantitative immunofluorescence antibody test, or flow cytometry, which basically these methods can measure how many viral proteins or antigens present in your samples, particularly in the cell culture. On top of that, you also can use a very rapid method known as real-time PCR, quantitative kind of PCR, where you can measure the viral genome. Okay, but how most of the time by measuring these only virus particles, you don't know how many infectious virus are there. So it is quite crucial or important to determine how many infectious viral particles are present, and there are many available methods can be used to quantify how many infectious particle of virus in your samples. So there are methods known as plug forming unit, tissue culture infectious dose 50, egg infectious dose 50, multiplicity of infection, HA titrations. Remember, we have covered this topic. And you have also another method to measure the lethal dose that causing death to animals or a population. And for TCID50, EID50, and LD50, you can use a method known as a read and nuance method, which is one of the, you need to use a formula in order to determine how many virus or how much is the concentration of your virus. Okay, so purpose of today's, for the purpose of today's practical, I will only cover 8 infectious dose, EID50. Okay, so how would you perform EID50? In this case, I use NDV, Newcastle disease virus, as example. So first, you need to do a dilution. First, you need to have your virus stock. Okay, so you don't know how much is the concentration of this virus. So you need to do 10-fold dilution. Okay, in each of tube or vial. So you do, for example, dilution 1 in tube 1, dilution 2 in tube 3. Basically, you just take 100 microliter of your virus stock, you add it in each of these tube. You need to have 900 microliter of PBS or distilled water. Most of the time for virus, we use PBS. Okay, so you perform serial dilution, 10-fold serial dilution, and then for each dilution, so you will have like, this is depends, you can do until dilution 10. Okay, so in this case, you can add more, dilution of 8, dilution 9, and dilution 10. So minus here is just referring to the dilution. And after that, what you need to do, you need to inoculate each of this dilution, for example, dilution 1 to the a group of 5 eggs. Okay, 5 eggs are in as a replicate. So meaning here, dilution 1, you inoculate into 5 eggs, dilution 2, another 5 eggs, dilution 3, another 5 eggs, 4, and so on. Okay. However, most of the time, because these three group, dilution -1, -2, and -3, most of the time, the virus are quite higher in this dilution. So most of the time it will give positive result. So most of the time we just discard it because we already know the result. So we will start like from -3, dilution 3 or dilution 4. So this is how it will look like. So for example, in dilution 3, you take the virus in the dilution 3, you inoculate into SPFX eggs via allantoid cavity because you know NDV can grow it in the allantoid cavity. So you inoculate each of this egg with 100 microliter to 200 microliter of your dilution. So in dilution 3, you inoculate in 5 eggs. Dilution 4, you inoculate in 5 eggs. Each of the dilution, it is a must to have 5 eggs as replicates. So you continue until -10. Okay. And remember, as I mentioned earlier, you need to inoculate via allantoid cavity. So for this method, apart from NDV, you can use for IDV, and you can use also for avian influenza. Okay, then what you do, from each of the eggs at each dilution, you need to perform rapid HA test, whether there is presence of a clump or agglutination or not. Whichever eggs that produce clump or agglutination is indicative as positive result. So basically, this is just an example. After you perform it, you need to uh, uh, at the same time, when you perform this HA test, you also need to tabulate the table. Okay, so this is an example in dilution 3. So you take each of the 5 eggs, you perform HA test, you found out that 5 out of 5 eggs produce HA positive, whereas 0 HA negative. Why 0? Because you have only 5 eggs per dilution. So you continue for the other group. So this is just an example. So group -4, you got 5. -5, you got 5 also. -6, you got 5. So basically, why I said we skip -1, -2, or -3, most of the time we already know this group will produce like all HA positive. So sometimes we just take like -3 or -4 as a starter, not like we just skip the earlier. Okay, so you see the variations of result as the dilution increase. So what does it, in theory, what does it indicate? As higher the dilution, the amount of virus will be low. That's why you will get less positive result. Okay, so what will you do next is you will need to determine the EID50 based on rate and range calculation method. So I also give you here a link on a detailed link or comprehensive link how to perform this. So basically this is the formula: percentage of infected at dilution immediately above 50% minus 50% divided by percentage of infected at dilution immediately above 50% minus percentage of infected at dilution immediately below 50%. So this is how examples. Okay, I'll show you. Okay, let's say here in this is examples from the link I showed you just now. So basically, in this example, they start from -6. Okay, so imagine in -6 you got 5 positive HA, 0 negative HA. In -7 you get 4 positive and 1 negative HA, and so on. So you already tabulate the results, and then you need to tabulate another table here. Okay, I think I need to go to this link because this is already the next step. So wait, that link will show to you how they get like 11 and so on. Okay, this one basically this is the same result as just now. Okay, this is 5x for -7. Okay, and this is the positive result and this is the negative result. So you need to add one more column that designated as accumulated numbers, and you need to subdivide it into infected versus non-infected. So in here, how you get the accumulated numbers of infected, you need to do ascendingly from the least dilution uh, addition of these positive numbers cumulatively. So for example here, what happened is for the infected one, okay, you start from below. So you have 0 here, okay, and then you have 2, 0 plus 2 equal to 2, and this 2 plus with 4 will be 6, and this 6 plus with 5 will be 11. So this is accumulated numbers for infected group. You need to do ascendingly, but from the least dilution. Whereas for the non-infected one, you need to do it vice versa, where you count it from the most dilution and you go descendingly. Okay, descendingly. So what happened here? Here will be 0. 0 plus 1, you will get 1. 1 plus 3, you will get 4. 4 plus 5, you will get 9. So this will give you an accumulated numbers of infected versus non-infected. After that, you need to add the infected and non-infected for each dilution. So here you will get 11 for dilution 7, dilution 8, you get 7, 6 plus 1, 2 plus 4, you got 6, and 0 plus 9, you got 9. Okay, so basically what does A and B indicate? A are infected and B is the non-infected, cumulated number of infected versus non-infected. So here, you need to add in one more column indicative of percentage of infected, where it is like total number divided by infected plus non-infected. So here will be total number tested 11 over all. Okay, and here will be 11 infected over all. So 11 infected here over all, 11 over 11, you got 100%. Here you get 6 over 7 infected divided by total. Here infected is 2 divided by total, and here is 0. So you get the percentage. Okay, you will see here at -7, you get percentage of infected 100%. At -8, you get 86% infected. -9, you get 33%, and at -10, you get 0% of the eggs were infected. Okay, so based on this formula, okay, percentage of, you get dilution 8 is the percentage above 50 because you need to fit in this formula. So percentage above 50 is 80, so here will be 50%. And so percentage above 50 is 86%, and percentage below 50% is 33%. So you just put in this formula. So 86 above 50 minus 50. Okay, this 50 just follow from the formula, divided by percentage above 50 minus percentage below 50. So 86% minus 33%. So you will get index of 0.7. So index of 0.7, okay, and this index this index will be useful when this index is the okay, I'll show you how. So here the percentage above in between 50% is minus 8 dilution. Okay, so here above 50%. Okay, so this index you add it in this dilution. So you will get the reciprocal of this dilution is the amount of virus contained in the 0.1 ml. Where you get the 0.1 ml is actually from the 100 microliter of virus you take from the original suspension. So you get the EID 50 of 10 to the power of 8.7. Where you got this 8 is from the dilution 8 because it is the immediate dilution which is above 50%. And this index, where you get this index 0.7 is basically from the Reed and Munch method. So it will give you a dilution of 8 to the power of 8.7 EID 50 in 100 microliter of virus. So how we want to calculate it if you want to know in 1 ml how many infectious virus are there? So you just add in you just times it with 10 to the power of 1 because 100 microliter to 100 microliter to 1 ml, you just add 10 to the power of 1. So you get here 8.7 plus 10 to the power of 1, you get 10 to the power of 9.7 EID 50 per ml. So basically this is the concentration of our virus in EID 50 per 1 ml of virus suspension. Any question, class? You got it?
Hello, doctor.
Yes?
For the dilution, right? So we choose the figure that nearest to the 50.
Yeah, above 50.
Oh, so if example have 70, so we took 70 or 86. For example, we have like another figure above 50 at the diagram. So we choose 70. Is it we choose 70 or 86? So we choose the nearest to the 50.
So here
If
you take between, right? Between 50%. For the index, you take between 50%. For the
oh,
dilution you take above 50%.
okay, okay. Oh, I understand.
All right.
Okay.
These numbers could be various. I have encountered in one time 100% and 0%. 100 and 000. So that one will be like you just follow this formula and you will get the concentration later on. Any other question, class? So I guess there's no question. So basically, okay. Actually, that's all for the practical part. And for today, there will be no assignment, okay? Because I'm thinking like 2 is enough. Okay, so I will cover one lecture topics today. And I will have one more session with you, lecture session, which is in this Wednesday. However, I couldn't make it because I have something urgent to settle. So for this Wednesday will be replaced by Dr. Nur Fitria, and I will take over that session probably in 2 weeks' time. Okay, later I will make arrangement with Sarvesh. Okay, so before I start the lecture, I want to show you a video. Okay, you guys are with me, are still with me, right?
Yes,
Yes, doctor.
Yes, doctor.
Can you hear?
No, doctor.
Oh, because I'm using my desktop. This desktop don't have um no sound, so probably
Bit about you and your heritage.
My family background, I would say, is entirely Cuban.
What sort of percentage do you think?
100%?
Oh, 100%. Okay, so 100% Cuban. There's a little bit of rivalry to your nearest neighbors, do you
There
think?
is, I think. I think Cubans don't like to be confused with the Dominicans, and not either way, like Dominicans with Cubans. I don't know why, but there is a rivalry there. My grandmother has 12 sisters and brothers, and I have 7 uncles.
So the whole family, all born in Cuba, all generations back as far as you can remember?
Yeah, I know there is something with my grandmother, sorry, my grandmother.
Maybe Dominican.
I hope not. A DNA test, I would love to do that, yeah.
And what that does is then we can step that back up to 2,000 years ago
2,000
and
years.
tell you.
Sorry guys, I think this is not the right video.
Hello. Hello.
Probably I don't want to continue. It's okay. I will just give you the link later on. So just continue with the lecture. So what I just want to show you in the video, I think some of you might have seen the video. It's just telling you about the variations of our DNAs, but somehow, regardless of where we are from, either we are from Europe, UK, somehow based on the DNA test, you can show that we have a common ancestral lineage. We share some common ancestral lineage. So which is actually make us as a human. So this is just, I just want to show you that. So I want to relate it actually with our lectures today. Okay. Can you name one of the family of virus that prone to undergo mutation before we proceed to our lecture today? So basically, why this we have like different traits among like us in Asia, Asian people with the European people, with the US people, with Chinese in China. So basically it's because of the mutations, slowly occurring of mutations, but somehow we are still from a same organism, which is human. Okay, can you hear me?
Yes, doctor.
Yes.
Okay. So can you name one of the family that are prone to undergo mutation?
Coronavirus?
Okay, very good. Apart from that, okay, Kevin answer. Nah. Apart from coronavirus,
Influenza virus.
sorry?
Influenza.
Okay, influenza virus. Very good. So this influenza virus is fall under category of Orthomyxoviridae family. So based on a recent classification by ICTV 2017, Orthomyxovirus are further classified into 7 genus. So previously it's just like 4 or 5 genus if I'm not mistaken. Nowadays it has been expanded into 7 genus. So we have alpha virus, which is actually infected human and animals. Delta and gamma most of the time infect human. Isa virus mostly affect fish, and you have Togoto virus, which mostly is the arbo-borne virus or arthropod-borne virus. So basically, these virus under automyxoviridae, their genome are segmented. If you still remember some of the virus, they have clinical genome, they have double-stranded genome, and what is interesting about coronavirus and automyxo or influenza virus is that they have what is the identical similarity between these two group of virus, that they have segmented genome. So because of these genomes, they basically they are the main reason why they easily undergo mutation. Okay, they are very full range of influenza virus. Okay, this is examples of influenza A virus. You name it, any animals, okay, and human can be infected by all A, B, C, and D. Whereas in influenza B, you have human, pigs, and seal. Influenza D, you have horse, human, cattle, camel, sheep, and goat. And influenza C, you have men and pigs. Okay, so basically, in influenza A, most of the time it causes epidemic influenza in man. Okay, and most of the time respiratory or generalized infections in horses, pigs, and birds, and they exist in multiple subtypes. This influenza A. Okay, so you can see why it exists in multiple subtypes, because the range of hosts are what varies a lot, numerous. Okay, influenza B. I just give you 3 examples here. Okay, B and C is causes of sporadic influenza in human, and there is one occasion of epidemic influenza in human under influenza B, which is Spanish flu, pandemic Spanish flu, which occurred in 1918. Okay, so automyxovirus is actually originated from myxa, Greek word meaning mucus, and auto meaning correct or right. Okay, um, this one is not true, only influenza A important, which is because probably this is my old notes. So not only influenza A, right, last, I showed you just now. Okay, so for mammalian influenza virus, most of the time the infections are local, which involve respiratory tract. However, in avian species, it involves, this is true in the case of very highly pathogenic avian influenza, such as in the because respiratory syndrome, central nervous syndrome, and intestinal infection. Okay, this is how the virus looks like. Okay, the variants of automysovirus are pleomorphic, meaning it has many shapes. Sometimes it is filamentous, like this, sometimes it is spherical in shapes. It depends. The shape is uh, depends. It might be different due to the stage of the viral replication in the cells. Okay, they have the diameter is about 80 to 120 nanometer, and it consists an envelope with large spikes. Okay, so it has like 6 to 8 helically symmetrical nucleotide segments. The genome consists of single-stranded negative sense RNA divided into 6 to 8 segments, and the size of genome is varies approximately 10 to 14.6 kilobyte. Okay. Although this automysovirus is a RNA virus, however, the replication takes place in the nucleus of the host, and the maturation is by budding. Okay. And because it is envelope virus, so because of that, it is sensitive to heat, acid, and lipid solvent. Okay. Until 2009 and now 2020, there are 18 subtypes of heme agglutinin and 11 subtypes of neuraminidase. These numbers are changing in class. If I'm not mistaken, last 2 years when I teach this topic, the H proteins is only 16, whereas N is only 9. But recently, they have found another 2 subtypes in the bats, subtype 70 and 80, as well as neuraminidase 10 and 11. So basically how we get these numbers is actually based on the number of envelopes. So we see here the blue color indicates the H protein, while the red color indicate the neuraminidase protein. So these numbers actually represents at which subtypes they are belongs to. Okay, in theory, by multiplying 18 H subtypes with 11 N subtypes, you will get 198 serotypes. Okay, in theory, theoretically. But however, so far in nature, only 131 subtypes have been detected as for November 2019. Okay, so they are frequently occurring of interfering particles and genetic reassortment between these nucleotides of this virus. It somehow resulting in antigenic shift or antigenic drift. So these are the mechanisms uh, co- are how coronavirus, how influenza virus undergo mutation. So it is divided, it is either antigenic shift or antigenic drift phenomenon. So for antigenic drift, it is actually the mutation is causing minor changes in the antigenicity, whereas the antigenic shift it causes major change. Okay, so for antigenic drift, it most of the time it will just change the epitope. Okay, so this is the examples. You have a pig infected it with H3N2 strain, and it already developed antibody to this strain, and uh, then this because of the antigenic drift, minor change in this epitope, resulting in the new strain still denoted as H3N2. However, the antibody could not, respond to this epitope because it's already from a new epitope. So it will lead to the next flu season in a particular population. So most of the time, it is sometimes if it is a very naive population, it will lead to epidemics. However, it's just a minor changes which just lead to the changes in the strain, either highly pathogenic or low pathogenic, like that. Severe pathogenic or virulent strain versus non-virulent strain or less virulent strain. Whereas on the other hand, the antigenic shift, it is a major changes in the orientation of these segments in which you have, the prerequisite for this antigenic shift to occur is that you must have two different strains of AI where the co-infection happen in one host. So co-infection meaning these two strains um, together it infect the host, and because uh, we have two strains, the segments between these two will reassort among them. And because of that, it will produce a new subtype. So if you see here, H1N1 co-infect with H2N2, you produce a new subtype here. Okay, H1N2. Any question, class, about this mechanism? You understand, right? It's quite straightforward. It's quite, thank you, quite straightforward. Okay, this is an example how like most of the new subtypes produced in nature right now, most of the time it is because pre-assortment between human and avians, between wild birds and commercial birds, between pigs and birds and human, and you will see later on the examples of reassortment which are caused by antigenic shift. Okay, so basically, how to name a flu virus? They are a systematic method. This is the method on how we name flu virus. So start with virus type, whether it is genus A, B, or C. Place of the virus was isolated. Okay, for example, here is Sydney, and the strain number, and then year isolated, and what is the subtype. So this is basically how naming of flu virus is being carried out. Okay, so you will see in influenza virus, as I mean, this is quite complicated because it's easily undergo mutation. So naming of it or grouping of it is quite important. Okay, so this you will see here, you can see here. So influenza A normally it being subdivided into subtypes. Okay, subtypes as I mentioned earlier, how many H protein, how many N protein, and these subtypes will further subdivided into clades, and this clade will be divided into subclade. So in terms of phylogenetic tree, so most of the time one clade will derive or originated from common ancestor, and this clade will be subdivided into subclade here. So I think you are familiar, right? In avian influenza virus, we always hear like clade, clade 6B, clade 3C, and so on. So just want to show you how this is being done. Okay, this is an example of clades and subclades of avian influenza presence in the world. So in each country, you have like, for example, here you have clade 2.2, and here you have clade 2.2 and subclade 2.3.2. So how you want to know each of this clade belongs to which country or which origin or geographical origin, you can refer to OIE. Okay, so now I will move on to avian influenza. Okay, so basically, in how does avian influenza originated, or what is the main cause of avian influenza outbreaks? Okay, previously we only think that this avian influenza was only derived from wild birds. If you see, if you study, they are in each of these subtypes, H1 until H16 and N1 until N9 subtypes, neuraminidase and heme agglutinin subtypes, most of them are present in wild birds. Whereas in other species, it just like not all of that subtypes are present in other species. This is because wild birds are the main reservoir of avian influenza virus or influenza virus, and most of the time they won't show any clinical signs. And ducks is also one of the wild birds. Also, always show positive influenza virus. And on top of that, occasion of fighting pox, which is quite famous in Southeast Asia, like in even in Malaysia, in the eastern region, and some places in Thailand. So cockfighting is actually one of the reasons how avian influenza originated. And live poultry markets. Live poultry markets is quite also common in China, in Asia particularly, in Southeast Asia, in China. So these are the area where the mutations or the reassortments of this avian influenza will occur. And most of the time, the one that we are afraid of is the highly pathogenic avian influenza. And studies have shown that these occasions uh, are the origins or the source of the occurrence of highly pathogenic avian influenza. So in general, there are two types of avian influenza: low pathogenic avian influenza and highly pathogenic avian influenza. Basically, all subtypes H1 until H16. I say H16 because H17 and H18 uh, has been found only in bats. Probably, I don't know. We need to check. Probably if it's not present now, probably it might be present in future. So basically, low pathogenic avian influenza occur in all subtypes. However, HPAI or highly pathogenic avian influenza only occurs. Low pathogenic avian influenza was first isolated from wild birds in 1972, whereas highly pathogenic is also from wild birds in 1961. Okay, so in terms of manifestation of clinical signs or illness, most of the time low pathogenic avian influenza it exhibit mild illness, such as ruffle feathers, drop in egg production, which most of the time might not be detected. However, in highly pathogenic avian influenza, it is manifested as severe disease with high mortality. Most of the time, if a commercial chicken flock is affected with highly pathogenic avian influenza, the mortality is most of the time will be 100% if HPAI is infected a flock of chicken. Okay, but it's not like true for the wild animals or wild birds. Okay, so this is important things to be take remark, because if you see later on in the flock of chicken there are high mortality, so you will suspect highly pathogenic avian influenza. Both strains are rapidly and contagiously spread. Okay, how does this manifestation or mild or severe is happening in, for example, in low pathogenic avian influenza? Why it's mild? Because they have only a single cleavage site for protease. So the moment low pathogenic avian influenza enter the host, which is the chicken, these sites, these cleavage sites only a single site present, which is only located localized at the upper respiratory tract. So because of that, most of the time low pathogenic avian influenza, this pleurisite will determine success, the rate of success, whether the avian influenza can replicate or not in the receptors or tropism or the target cells. So basically, because these receptors of protease is only present at local part, that's because the most of the time the infection is localized. Okay, and the clinical signs are also mild. On the other hand, for HPAI strain, the receptors or the cleavage sites of these protease is ubiquitous in the host. So you can see here, you can see these sites are in the respiratory tract, in the GIT, and also in the brain. So because of that, this will lead to systemic infection. Talking about localized and systemic infection, and also about protease, these protease in the low pathogenic avian influenza only present in the epithelial cells. Okay, these receptors only present in the epithelial cells. Whereas for highly pathogenic avian influenza, these receptors present in the epithelial cells and endothelial cells. So the moment if the replication of virus taking place in the endothelial cells, you will see systemic infections and severe manifestation of the disease, and you will see a loss of hemorrhage in the internal organ. So, as I mentioned earlier, for HPAI, the subtypes only H5 and H7. However, this H5 and H7 also can be categorized as low pathogenic avian influenza. So, how will you know? How will you differentiate between these two? Is based on the clinical signs, based on the mortality rate, based on the post-mortem lesion, localization or systemic lesion, as well as based on the sequencing of the virus. Okay, so this is one of the examples impact of outbreaks happen in Malaysia, H5N1 avian flu outbreaks, where it lead to these restrictions of imports from outside country. So what happened in Malaysia? We have actually encountered outbreaks of highly pathogenic avian influenza, which back in 2004, there were outbreak in Kelantan, 2006 in the northern state and the central states, in 2007 in Selangor, and recently in 2017 in Kelantan. And the most recent one in the Borneo is in Tuaran Sabah, which is isolated in 2018. So most of the, based on the study, this Kelantan a common site where highly pathogenic avian influenza occur because of the fighting cocks. They love to play with the fighting cocks or game birds, and that's it's not because of the outbreaks in the commercial chickens. Whereas in the Tuaran Sabah, the outbreaks was actually happened in the commercial chickens, and the source of infections is actually from wild birds. If you look into the area where the farms was located, it's actually very nearby to the coastal regions, and this is the most of the time the sites where the wild birds will be there mingle around. Okay, what about low pathogenic avian influenza? There is one strain known as H9N2. It is although this is the low pathogenic strain, however, it caused severe economic loss to the poultry industry in Malaysia. And these are the sites that have been experienced outbreaks of H9N2, low pathogenic avian influenza infections. It concentrated at the West Coast Malaysia. Okay, so what happens that this LPAI cause reduced broiler growth rates, drops in eggs production. If you remember back in 2017, 2009, 18, if I'm not mistaken, there were no eggs right in the supermarket. So that during that time that it was due to low pathogenic avian influenza H9N2. So it also caused moderate to high morbidity and mortality, and also, as I mentioned earlier, because it caused drops in egg production. So basically, in layer chicken, the parts where it affected is in the infundibulum of the layer chicken. Okay, so unlike H5 and H7, H9N2 is actually not notifiable disease. Okay, so if you encounter any H5 or H7 outbreaks, regardless of low pathogenic or highly pathogenic, you must notify it to DBS, and DBS will notify it to OIE. So this far, so far, LPAI is not categorized under notifiable disease. However, it caused like a severe economic burden to a country. Okay, and based on the LPAI presence in Malaysia, it was actually derived from Eurasian lineage, and the isolates found in these regions was actually a representative of this lineage, G1 lineage, Y280 lineage, and Korean lineage. Okay, that's somehow about the low pathogenic avian influenza. In terms of pathogenesis, the pathogenesis of avian influenza, the mode of infections is via injection or inhalation. It's not only by inhalation, because remember, as I said just now, avian influenza also have receptors in the GIT as well as in the nervous system. Okay, and how successful is not the entry and the replication in the receptors at the entry sites, basically due to the presence of protease in the host tissue. And if that site happen to have this protease site, it will be activate the fusion and entry of the H and N protein into the epithelial cells, followed by replication and later on lead to viremia. And as I mentioned just now, for avian influenza, particularly highly pathogenic, it has receptors on endothelial cells, which is located in the blood vessel. So the effect will be like tremendous and therapeutic. Okay, so clinical signs of avian influenza. In highly pathogenic avian influenza, you will see signs of depression, loss of appetite, and excessive thirst, cessation in egg laying. You will see also coughing and sneezing, indicative of respiratory signs, ruffle feathers. Okay, this is quite general, ruffle feathers. Any infection will lead to ruffle feathers. This is normally a secondary due to dehydration. And you see here, this is quite characteristic in highly pathogenic avian influenza. The chicken will show nervous signs, droopings of the wings, dragging of the leg, twisting of the head and neck, circling, and complete paralysis. There's also occurrence of swelling and blue discolorations of foam and waters, blue discolorations of the shanks, okay, shanks here, and diarrhea. Remember, as I said just now, apart from respiratory signs, nervous signs, there will be also examples of GIT signs, which are diarrhea, sudden death, and also pointed earlier, for highly pathogenic avian influenza, commercial chicken, most of the time, the mortality rate is 100%. Whereas for low pathogenic avian influenza, it lead to mild respiratory disease, depression, and drop in egg production. Okay, this is the examples of the signs or findings. Okay, you see here the swollen head, okay, discharge from the eyes, from the nose, blue discoloration of waters and foam. Sometimes it looks hemorrhagic, full feathers, twisting of the head and neck, uh, twisting the head or neck of the chicken sometimes goes as office tetanus, or in the case of NDV, you see, cannot recall if there's a name for this twisting of the head. And this is example of the blue discolorations of the shanks. Okay, so for the postmortem finding, you will see fibrinous exudates in the air sac, oviduct, pericardial sac, and peritoneum. There will be also hemorrhagic lesion in the visceral organs and the foam and water. Okay, this is examples of postmortem finding and clinical signs found from H5N1 HPAI outbreaks in Kelantan in 2017. Okay, the lesion is quite similar as I mentioned earlier, kinesis and edema of the comb, head and waters, red discoloration of the shanks and feet. When you cut open the carcass, you will see hemorrhages in all organs, pinpoint hemorrhage at the proventriculus, and the mesenteric blood also highly congested. This is the histopathological lesion. You can see generalized pulmonary hemorrhage with moderate interstitial pneumonia. This is from the lung. Generalized hepatic hemorrhage, hemorrhage in the myocarditis, hemorrhage in the nephritis, generalized hemorrhage in all of its system or the visceral organs. Okay, so how would we diagnose avian influenza? Okay, as you know, avian influenza is a virus that able to agglutinate the blood cells because it has this H protein, thin agglutinating protein, which is responsible to bind to the sialic acids on the red blood cells. So you can take from the live bird, you can take local swab or oropharyngeal swab. From the dead chicken, you can take whole organs, samples or feces, and you inoculate the samples into the electrode cavity of the 9 to 11 days old eggs, and you do the rapid HPV test, and you need to accompany it by confirmation whether you use that alerted sample. You can do immunodiffusion test, gel immunodiffusion test, or you can do HI test, which is very, very easy to do. And you also can also subject that samples to real-time PCR or uh, normal PCR, reverse transcriptase PCR. On top of that, in indirect method, you can also grow the virus in cell cultures such as the chicken environmented fibroblast cells or NBD cells. Okay, apart from that, in indirect technique, you can, when you already know that virus, you already confirm that virus is AI, so you want to know whether the virus is highly pathogenic or uh, low pathogenic or virulent or less virulent strain. So basically what you do is that you will inoculate this virus into animals and you will determine the IV pathogenicity index or intracerebral pathogenicity index. So for IV, okay, you inoculate 8 susceptible at range of 4 to 8 weeks of chicken with the infectious virus. And in this case, you already know it is influenza virus, but you don't know which strain. Is it highly pathogenic or low pathogenic? And if the strain cause mortality more than 75% within 10 days, they are considered highly pathogenic. Okay, and you also can inoculate 10 susceptible 6 weeks of all chicken, and if it is give IV PI index of 1.2, it's also categorized as highly pathogenic. And remember that because it is highly pathogenic, it has tendency to infect human. So be afraid of a new pandemic to occur. So most of the time, this must be this experiment, inoculation of influenza virus into the animal host need to be carried out in high containment lab, such as BSL-3 lab, biosafety laboratory level 3 lab. So on top of that, you also can do intracerebral pathogenicity index. Okay, you inoculate this virus into the cerebrum of the chicken and you observe the outcome. So if the chicks appear normal, it will be graded as 0, 6, 1, 2 death. So virulent strain will give a maximum score of 2, whereas the less virulent strain will give value closest to 0. This is how you diagnose what kind of strains that you are dealing with. Okay, and then on top of that, direct diagnosis from the samples either from without you inoculate it into the eggs, you can just take swabs, local swabs or the oropharyngeal swab from the chicken, you can straight away subject the test to PCR test, or you also can start with indirect technique and then followed by PCR. Okay, how you perform serological subtyping of avian influenza? So in each region, there are regional reference labs to perform this subtyping of avian influenza, whether H1N1 or H5N1. So you can use heme agglutinin and neuraminidase inhibition test, which is HI test. Okay, so you need to have the polyclonal or mono-specific anti-sera for each of these subtypes. Okay, so I wrote here 18 because 18 and 17 is from text. We don't know yet whether from it in the shipping or not, or put so just wrote here 16. Okay, and then the subtyping also can be performed using genome-specific HEN subtype using real-time PCR, and then you proceed with sequencing and phylogenetic analysis. Okay, serology, you can perform serology as I mentioned previously, mainly to determine the efficiency of our vaccine. So if you practice vaccination of avian influenza, you can do this test. But up to now, Malaysia did not practice vaccination for avian influenza, so none of the serological tests have been done to detect avian influenza because we don't have the vaccine, so we don't need to test the efficacy or efficiency of the virus. So basically, in Malaysia, the control of highly pathogenic is being taken care by DBS, and they follow this enactment in your X. And you can see this protocol, Malaysia Virtual Protocol in DBS website. Okay, and they also follow OIE recommendation. These are basically the control and eradication policies performed or carried out by Malaysia. You have eradication and control method. The policy is stamping out detection of H5 or H7 in bird population, confirmation with real-time PCR, compensation policy to the farmers, permits, also do surveillance, permits that confirm with HPAI, and this stamping out later on I will show to you that you have control zone, surveillance zone, and surveillance strategy, how you perform surveillance strategy, observe for clinical signs, and observe also for the virus, you do virus tests, and freedom of declaration is actually you can declare of freedom of HPAI after you get that. After 3 months final disinfection, you got like all of your samples of all your surveillance samples completely, you can like self-declare like you are free from HPAI. So this Malaysia has, DBS has self-declared that Malaysia is free of HPAI. So you can see that document available online. And in terms of vaccination, this far still prohibited in Malaysia, but we don't know. Probably this year or next year, Malaysia might be practice vaccination, not for highly pathogenic, probably for low pathogenic, because as we've seen in the case of H9N2, low pathogenic avian influenza, the effect is quite severe, particularly the economic effect. So this is how control of highly pathogenic avian influenza has been carried out in Sabah, Tuaran, which happened in 2018, back in 2018. So what happens is that they do this zoning and compartmentalization, where they divided the first zone, which is the affected zone. Okay, this is the affected zone. Okay, this is the affected area where the outbreaks was originated. Okay, so they have if you go to each regional DBS office, you will see in each regional they will have like, if you go to Selangor, they will have maps of Selangor. If you go to Kelantan, you will have map Kelantan, and you will see they have in their boards, they have this zone. And if any outbreaks happen in any particular zone, they will do this kind of zoning. So affected zone, what you do, this affected zone from the outbreaks happen in 1 kilometer radius, there will be stamping out, in which meaning that there will be immediate culling, okay, of that infected means all of the chickens will be culled, followed by cleaning and disinfection. And at this affected zone, there will be no movement of domestic birds permitted in and out of the region, and there will be enforcement by the police where roadblocks will be carried out along the border of the affected area. Okay, then you have at the second radius, which is 10 kilometer radius from this affected zone, uh, denoted as control or protected zone. In this zone, uh, there will be you will be subdivided it into two zones. 1 kilometer zone from the affected zone, all of the plots also will be depopulated, whereas the another 9 kilometer zones they will do surveillance, clinical inspection, sampling, and quarantine enforced for 42 days for the chickens. And third zone is the free zone. Okay, you see here free zone here in the case of Keluaran Sabah, all district which is not bordering the affected zone and other states, including Labuan, Sarawak, and Peninsular Malaysia. This is the free zone. What happened in this free zone is that because we want to declare the HPAI free status, so nationwide surveillance must be conducted a minimum of once per year in this zone, and it must cover poultry farms, duck farms, pet birds, quail farms, backyard farms, and pet shops. Okay. What happened in Sabah? A total of 34,000, approximately 34, nearly to 35,000 birds were culled, and 4,900 eggs were destroyed, which involved 313 premises there. Okay, so this is general avian influenza control, regardless of low pathogenic or highly pathogenic. Okay, so you need to just as you know, low pathogenic also can somehow reassert and will lead to this highly pathogenic avian influenza occasion. So that's why the moment you suspect there is an influenza outbreak, it is very crucial to warn and notify the outbreaks, because we need to do the test or the diagnosis as soon as possible. You want to know which kind of virus that you are dealing with, what subtypes, is it, if you know already the subtypes, for example, if it is H5, is it highly pathogenic or low pathogenic? So this is crucially important. So in the case of where you encounter outbreaks, zoning and compartmentalization need to be carried out, culling or stamping out, restriction of movement, strategic vaccinations is also being done in an area where outbreaks happen. This is also crucial, public awareness campaign. Remember class, one of the tasks that I gave you for task 2 is to do the public awareness campaign for zoonotic virus. So this is one of the preventive strategies to like educate public. In this case, it's the poultry owners about the knowledge about the disease. Okay, decontamination and disposal also is important. If not that these carcass or these animals do not dispose or decon properly, it will be the source of next infection. Okay, so for AIV avian influenza vaccinations. So far, not all countries worldwide practice vaccination. Okay, routine vaccination in the region is being practiced by China, Egypt, Indonesia, and Vietnam. Okay, you see here no Malaysia. Emergency vaccination like Africa, Sudan, North Korea, Russia, Israel, and Pakistan. Preventive vaccination being practiced by Netherlands, France, Kazakhstan, and Mongolia. Okay, so the decision to introduce vaccination mainly is taken by the local authorities. In the case of Malaysia, is the US. So, in many countries, vaccination is the major. This is in the case of H9N2. Malaysia so far did not practice vaccination for H9N2, H5, or H7, highly pathogenic and low pathogenic. But in the case of low pathogenic avian influenza H9N2, most of the countries practice vaccination to control the infection. However, it's not being still permitted in Malaysia. But this policy was made before H9N2 outbreaks in poultry. So it cannot be denied that although H9N2 is low pathogenic, it has caused enormous economic burden for the poultry sector in Malaysia. Since H9N2 has been endemic in Malaysia, control measures such as test and slaughter or stamping out approach may not be sustainable in the long run. So because of that, we don't know. Later on, probably Malaysia might have want to implement this vaccination against H9N2. Okay, so I would also to share with you guys the occurrence of pandemic influenza in human. They are in 1918 Spanish flu, which are when we try to study it, most of these outbreaks was actually this virus was reassorted from chicken in 1957. Asian flu was also the reassortment between chicken and human in 1968, between chickens and human in mid 2009. Swine flu reassortment between swine and human as H1N1, and um, not only swine, there are lots of animals which actually serve as mixing vessels for influenza. Back in 2010, there is a popular topic where swine is the mixing vessels, but as time increased, there's been also shown that cat and dog also serve as the mixing vessels of influenza virus. You can see here in the dogs, there is reassortment or combinations of human genes, human influenza genes here. We have ducks here, pigs genes here, and in the cats also. So the somehow this occurrence of influenza virus is actually due to reassortments between multi-species. Okay. So in dogs, there's also avian influenza in dogs and cats. Okay, so this is the examples of influenza virus detected in dogs and cats from UK, US, Canada, Southeast Asia, and they show the severity of the disease, whether it just causing mild infection or severe respiratory syndrome, and you can just look here. And it's also stated the origins of infection from human, from swine, and also equine influenza is also one of the infections occurred in equine. So basically, equine, as you know, it affect the international trade, and they are most of the time it occurred in the unvaccinated chicken. So far, there are two subtypes, H7 and H3, which is influenza. And just for your information, vaccinations against equine influenza is practiced in Malaysia. Okay, so what's actually happening between these avian influenza infection? Is animals being the zoonotic source of us, or we are the source of infection to the animal? So in reality, most of this happen. Anthropogenesis also happen. Some of the viruses were originated from animals, some of the viruses were actually originated from human, meaning that we are the source of infection. And remember, because this influenza virus, it has segmented genome. So because of that, when these viruses co-infected each other in different host range, that's why new subtypes uh, emerge. Okay, so what about the safety of meat infected with avian influenza or swine influenza? So according to WHO and FAO, it is safe to be eaten. However, you need to like properly cook it, and remember when you handle the chicken, when you want to wash, cut it also on, remember there's blood and secretions there, so you need to be careful. To be safe, just avoid it, to take the chickens infected with avian influenza. So that's all. Any question, class, regarding influenza virus? Okay, I guess there's no question. So I will end our practical session and lecture today. Now,
Doctor, I have one question in the chat box.
sorry.
I have one question in the chat box.
Okay, so basically, this cockfighting will lead to the stressful events in the host, in the chicken, right? So basically, what happens that, as you know, virus, when it is stressful events, it will like the infections will easily to occur, or if the virus is actually shed by the chicken, it will flare up. So what is that, as you know, human also have influenza virus. So most of the time these happen because of the many factors, stressful factors, and presence of many hosts in that so-called region. So probably there is co-infection between human influenza, this chicken influenza, and in live poultry markets, you can see not only chicken, right? You can see like in some regions in China, in Vietnam, there are reptilians, there are like wild animals. So these are the area which is really, really good for where mixing vessels of this uh, avian virus can easily undergo reassortment. So that's why this highly pathogenic avian influenza emerged from this cockfighting and live poultry markets. Why is vaccine for eye prohibited? So this is a very good question. In the case of avian influenza, particularly the highly pathogenic one, as I mentioned earlier, the occurrence of mutations is like easily to occur. You cannot like uh, tell the virus to stop to occur. No, it can happen uh, dramatically. These mutation rates are really, really high. So that's why it is prohibited in Malaysia. But as I mentioned earlier, for highly low pathogenic avian influenza, even we want to practice it later on, want to use it later on, it must be carried out with the closer or regular monitoring, and with extra careful, because we don't want this vaccine strain mingle around with this live strain or wild strain happening in the environment and somehow lead to the new occasions of mutation. Okay, that's basically why vaccine for influenza, for coronavirus, it can be produced, but with extra careful, with extra monitoring. In the case of human influenza, as you know, we have in Malaysia, we have practiced influenza virus in human. But however, whoever took that vaccine, you need to renew it every year, because every year this vaccine will be like somehow monitored and based on the current isolate prices, and it will be produced. In the new vaccine will be produced, and you need to take another shot. This will be true for this in the case of coronavirus later on. Any other question, class? Clear, right? My explanation. Any question, Florence? Did you get my answer just now?
Yes, doctor. Thank you.
What about Wanzing?
Doctor, so does that mean that vaccination will like cause higher mutations?
Not vaccination causing higher mutation. Remember, vaccine is made up of virus, right? Take examples of other viruses that you use as vaccine. There are a lot also infection caused by the vaccine, right? So what happens that probably we don't know, because we don't know yet. So this vaccine, this virus from vaccine might be there is high tendency this virus from vaccine will co-infect with other strains that present in this in the farm. And what happened, as you know, when there's co-infections of two strains of AI or influenza, it will lead to the new subtype, right? So what we are afraid of is the emergence of highly pathogenic subtypes. So that's why not to say that it is cannot be done. It could be done, but with extra careful, extra precaution. You need to always look into the floods, look into the environment. Need to do lots of tests, diagnostic tests, whether there is presence of virus or not. You need to do lots of surveillance and monitoring. Okay.
Doctor, also I want to ask, is it like the virus on your chicken is like naturally occurring like that?
Sorry, is it that?
It's like the virus that the chicken, I mean the in the cockfighting, involved in the cockfighting, does the cock like naturally mutate like that?
Sorry, not clear. Maybe you can type. So is it like the virus, the cock has is naturally occurring? Naturally occurring. Like the cock is the natural host. So basically for AI, any species or any host can be the natural host, or because this subtype is actually present in many hosts, right? So yes, it is naturally occurring, but when I say naturally occurring is of course it has been like a reassortment with human gene, with animal genes, and so on, because these viruses are keep on mutating. So in order to confirm it, uh, whether, especially when you want to know the virus is actually contain what from the origin of this genes or this virus from which host, you can do full genome sequencing, and you can see especially at the H and N nucleotides regions are each shared with which host. So you can see that, and from the analysis, actually this strain that we got is actually shared between which host. Okay. Right. Any other questions, class?
Doctor,
Yes.
I have one question. Around 2006, I think in Hong Kong, a case human infect with avian influenza, DH5, because they eat raw chicken meat.
Okay.
So what the degree, the temperature to kill this virus?
Okay, the exact temperature I'm not sure, but probably that um case of human death due to avian influenza are there actually, but the occurrence or the incidence is quite low. So probably the one that you shared just now, which happened in China, probably this person took the chicken raw, probably not properly cooked. So that's why it became the source of infection. So particularly the exact temperature, I'm not sure, but as you know, this is envelope virus, so probably less than like 40 to 60 degree, actually enough to kill the virus probably in 15 to 20 minutes, but that's just my guess. You can you can check it, the proper temperature.
Okay.
Okay, so I guess there is no other question. So remember to sign in your attendance into Shablas. So I will see you later on in mix of December class. Don't forget to submit your practical assignments which due is in this Friday. And I hope you also are working on with your test two. Remember, for my part, have 10 marks allocated for test two, but it's just a very simple work. You just need to conduct a public awareness campaign, and the details of that campaign I have included in the Berna video lecture. So I hope you aware about it. Okay, class, thank you so much for your time and attention. See you later. Bye. Assalamualaikum. Good afternoon.
Bye,
Thank you,
Doctor.
doctor. Bye. Have a
Bye,
good day.
Thank you
Doctor.
so much.
Thank you.
Thank you, doctor.